Welcome back. In this video, we are going to talk about slices in Go. And before we get into that, to better understand what slices are and how they work, we need to know and understand what an array is. And simply, an array is a data structure, and it stores elements of one type in sequential order. So an example of an array that stores 5 integers could be represented as such. Each box is an index in the array, and each box holds one integer element. So an example of an array that's size 5 with 5 indexes could have these values in them: 1, 2, 3, 4, and 5. And notice that the index of each element the index starts at 0. So if you want the first element in your array, it would be at index 0, and then 1, 2, and so on. So, as I have written here, to get the value at an index in an array, for example, if we wanted the last value, the value of 5 here, we would write array at index 4, because at index 4, it has the last value of the array, which is the 5 here. And this array here could be any name that we use to name our array variable. I'm just using array here. But this line right here pretty much says to return the value at index 4 in our array, which would give us the integer 5 in our case. So that is a quick overview of what an array is. Okay. So, before we move on, let's do some quick code examples using arrays in Go. So I'm going to open Visual Studios and create a new Go file. Just going to save it on my desktop, and I'll call it array.go. Okay, package main, function. So to declare an array in Go is pretty similar to declaring any kind of variable. We just write the variable name. I'm just going to call it array in this case. And we use these square brackets to note that we are going to be creating an array here. But inside the square brackets, we need to put how many elements our array is going to hold, so the length of our array. And we're going to use the same example as the PowerPoint slide, so we need an array of size 5 to hold 5 elements. So we put 5 in here. And then we need to put the array type, so what kind of elements this array is going to be holding. And we're going to be holding integers, so we write int, and then curly braces, and we can pre-initialize the values in each index with 1, 2, 3, 4, and 5. Now I'll save that. Okay. And we can print all the elements in our array using the for each loop that I talked about in the last video. So I'll do that really quickly. And then I will run this. I'll just use the terminal inside Visual Studios Code for today. Make sure you are in the correct directory of where your Go file is. I'm in the desktop actually. Okay, and then go run array.go, and we can see the array at index 0 has the value of 1. The array at index 1, the array at index 1 has the value of 2. The array at index 2 has the value of 3, and so on. Same thing here. So that's how we can declare an array and initialize the initial values in each index. You can also use the built-in length function to get the length of your array. So we'll just print that as an example. So this is a built-in function, len for length, and then you just pass in your array variable, and that function will return the length of your array. So run this, and as you can see, we get a 5 printed out here because our array is of size 5. And you could also create an array and not have initial values in it, as in our 1, 2, 3, 4, 5 here. So as another example, let's say my array, and then this time it'll be of size 10, and it'll hold strings. And you can just do empty curly braces, and this will just use the default 0 value for all your elements. So it would just be an empty string in this case. But if it was integers, it'd be zeros. And to show that, we can just print that really quick. And we'll also print the length of this array, just to show you that even though it's empty with no initial values, it's still size 10. Hopefully there's no syntax error here. Let's see, undefined. Okay. Yeah. There we go. Okay. So as you can see, we get our array printed out, and there's just empty strings in there, so we don't see anything. And it's printing out the size of our array, which is 10, which is correct. And then another way you can actually declare an initialized array is have Go count the number of elements for you in your array and not actually pass in the length of your array inside the square brackets. And you can do that like this. Let's call this another array. And then we'll also use strings again. String. And we'll initialize it with the following 3 strings. Go is awesome. And so in the square bracket, instead of putting 3 in our case, we put ... And that will have Go count the number of elements there for you. And to show you that this works, we'll print our array. And then we'll print the contents of the array. And then we'll also print the length of the array. Save that, and we run it. And as you can see, we get our array printed with our 3 strings in there. Go is awesome. And we get the length of the array printed, which is 3, which is counted correctly because we have 3 elements in here. So you don't have to print the array like this, like I did earlier with a for loop. You can just pass the array to the print line function. You'll just print it out like this with square brackets to show you that's an array. Okay. So that's a quick code review of how to create an array and the built-in function length. All right, so back to the slides. Oops. Okay, and a quick side note about arrays in Go. Array variables in Go are values, and they represent the whole array itself. Is not a pointer to the first element in the array, such as in C or C++. If you've programmed in those languages before, you would know that arrays are a sugar-coded syntax in C, C++, and it actually refers as a pointer to the first element of the array. But in Go, that's not the case. The array variable is actually the whole array itself. So when you pass an array to a function or assign it to another variable, it creates a copy of the array elements. You're not manipulating the original array itself. Okay, it's a quick side note. Next slide. So now we're going to talk about the limitations on arrays. So arrays are the most primitive data structure and only have a set fixed length. Primitive data structure meaning that pretty much every programming language has this built in. It's the most simple and intuitive data structure there is, but like I mentioned here, the downfall is that there's a fixed length and we can't change it. So this creates a problem, right? What if you don't know how big of an array you need? Like, you don't know how many elements you need, or it's dynamic. Such, for example, if you had an array that holds the number of, or just holds the name of students, for example, and what if students leave your class, you get new students, and that changes. So that's dynamic in that sense. So this creates a problem. We don't know how big it should be, and so a possible solution could be you just create a large array, and that'd be that. But as I have here, if we create a large array, it's a waste of computer memory, because if we never use those allocated spots, then we're just wasting memory. But then if you create an array too small and you need to add more size, then, well, now you gotta copy everything over to a larger array, and that's costly in time, because let's say we had an array of 10,000 elements, and now we need to add one more element, and we need a bigger array. We have to copy over 10,000 elements to the new larger array, and that's, again, time costing, time complexity, and the fact that you have to actually write that code too. So this is where slices come in. And before we go to coding slices, we're going to look at how it works and how it looks internally. So we'll visit this link on the Go website. Hopefully it opens for me. Whoops. Okay. Nope. Okay, here we go. Let me move this over from my other monitor to this screen here. Cool. Okay, so, sorry, gotta pull something up again. Make sure you guys are seeing what I'm seeing. Alright, good. So, the internals of a slice. This is directly off the Go website, Go documentation, so it's there if you want to look it over again yourself. So, this is how a slice is internally in Go. And as you can see, it contains 3 components here. It contains a pointer to an array, the length, and the capacity. So if you don't know what a pointer is, that's okay for now. I'll make a separate video on that, and pointers are a somewhat complex topic, and a lot of programmers and software engineers actually have trouble with this topic. So in a future video, I'll try to do my best to explain this, and if you do understand pointers very well, you're actually above a lot of software engineers. But anyway, so this is how a slice is internally in Go. So we have a pointer that points to an array. We have the length and we have the capacity. So if we create a slice with the variable s, as they showed here, they declared it up here. This is how it would look. You would have an array of size 5 with a length of 5 and a capacity of 5. This slice holds byte types, by the way. So the pointer is pointing to an array of size 5. And then, so that's pretty much the internals. So if you know what a dynamic array is, it's pretty much, a slice is pretty much a dynamic array, like the array list in Java and vector in C++. So you could think of it like that. Okay, so moving back to code, we'll write some code to go over how to create a slice and some functions that we can use for it and some operations we can do on it. So here's the syntax for declaring a slice variable. We have 2 ways. We can write it this way: variable name, assignment, initial assignment thingy, the shorthand for declaring initial variable. We can use the make keyword and then square brackets. Keep in mind, when you're declaring a slice, you do not put anything inside the square brackets. then the data type, as in what type of data our slice is going to be holding, such as integer, float, string, or even your own custom type, which we'll talk about another time. The length of our array, and an optional capacity. Or you can do it this way, variable name for the slice variable, square brackets, the type, and then whatever initial elements are in here. You can leave it blank too. It'll just be empty. It'll just be an empty slice of size 0, length 0. So how do we add new elements to a slice? So you can use the built-in append function if you want to append a new element to the slice. But you have to keep in mind that the append function always returns a new slice. If you want the length of the slice, we can use the built-in function length, which is the same function that we used to get the length of the array earlier. And then if you want to copy one slice variable to another slice variable, you can use the built-in copy function. This is the function signature. So the first parameter is the destination slice, and the second parameter would be the source slice. So everything from the source slice would be copied over to the destination slice. So now let's write some code. Going back here, I'm going to create a new Go file, and I'm going to call it slice.go or slices.go. Package main, function main. Sorry, I have a little script on the side to make sure I don't forget anything, so I'm taking a look at it really quick. Okay, so let's create a slice variable. I'm just going to call it my slice, and then I'm going to do the empty square brackets, and then our type. So let's just do a float 32 slice, meaning that our slice is going to hold float 32 elements, and I'm going to create it with nothing inside of it initially. And then if I print this, you should see that it's empty, so nothing should really print here. Or nothing should really show up except for the square brackets, probably. What is this? Main redeclared previous declaration. Yeah, that's an issue. Okay, that's fine. I'll just delete all of this for now. Don't worry, all the code is gonna be on my GitHub in one file. Oh, sorry. Ran the wrong file. Let's let go. And as you can see, we get a empty slice printed because there's nothing in there. I did not initialize it initially with anything. So now we can create another slice using the other syntax I showed you, using the built-in make function. I'll go over the make function in another video too, but if you want to go find out for yourself ahead what it does, then you can look it up on Go's documentation. But you write float 32 make, so use the built-in function make first, and then the first parameter will be the slice, so empty square brackets here, and then the type float 32 again, and so we have to pass in a length parameter like I showed you in the slide. I'm just gonna say 2, so the initial length is 2, and you can pass an optional capacity parameter, but you don't have to. If you don't, it'll just use whatever you pass in here for the length. So it'll be 2, since I didn't explicitly say what it should be. And then if I print this, you should see that it's also empty. Oh, actually, oh no, it's not empty because I initialized with the size of 2. So it just fills in the empty spots with 0 value for float 32, which is 0. Sorry about that. That was my mistake. It's a long day. And I'm sorry if I'm talking kind of quiet. My dog's sleeping. Okay. So that's how you declare and create a slice, the 2 ways I showed in the slide. And now we're going to look at the append and copy function. So the built-in append function adds a new element to the slice. So if I take the first slice here, my slice, and I assign it the return slice from the append function, and let's say I add the two values 3.14 and 3.199. So what happens now is it takes this slice that you passed in and it adds these two values to whatever's already in here and returns that new slice and assigns it to this variable here. Remember that this function always returns a new slice. It is not modifying the slice here. So now if I print this, t.print line my slice, you can see that our two values was added. Initially it was empty, and then we appended these two values. This can be as long as you want, actually. It's like I could add more values here. But yeah, like I said, this append function returns a new slice. It does not modify the original slice you passed in here. So, moving on. If you want to reassign a value in a slice, for example, since my other slice has the two zeros here, I can replace those with values if I wanted to. So let's say I wanted to replace the first element in my other slice, which is 0, and I want to replace it with, let's say, 13.37, then I say my other slice at index 0, this is what square brackets at 0 mean, is saying at index 0 of this slice, I want the value to be 13.37. And then if I want to change the second element, which is at index 1, so my other slice at index 1, I want the value of 319.95%. Now, if I print this slice of my other slice, you can see that we get 13.37 and 319.95 printed. Originally, it had these two zero values, but I replaced them with these two. Doing this is modifying the original slice. This is saying that at index 0 of my other slice, this is the value, and at index 1 of my other slice, this is the value. This is not an append where we're adding a new element, we're replacing it, or we're changing the value at an index. And now to show you how, as an example of the copy function, let's copy the data from my other slice into my slice. Originally, right now, my slice contains the values of 3.14 and 3.199. So we want to copy the values from my other slice, which is these two, to my slice, which is these two. So then both slices will have the same values. So copy, it's the built-in function copy. So the first argument that we pass in is the destination, the destination slice. So in our case, it's going to be my slice. And then the second argument we pass in is the source slice, which is going to be my other slice. So we call that function, and then to show you that it was copied over, I'll print out my slice. And as you can see, my slice, which originally had 3.14 and 3.199, now has the same values as my other slice, 13.37 and 319.95. Okay, so those are the built-in functions, copy, append, and copy and append. I was going to say length, but we already went over that. And that's how you declare and initialize a slice the two ways. Now, we are going to go back to slides really quick. We're going to talk about the slice operator and how we can remove elements. So this is the syntax for the slice operator, the variable name for our slice, and then the indexes with a semicolon and then another index. So index, semicolon, index. So, the index from the left, semicolon, index to the right. This will make more sense once we go over the code, or actually right here. So, for example, if we have the following slice containing these values, 0, 1, 2, 3, 4, and 5. If I write the following syntax up here, assuming our slice is called slice, square bracket 0.4, so 0 representing from left, 4 representing to right, we get returned a new slice containing the elements from index 0 from the left, inclusive, to index 4 to the right, not inclusive. So in our example, writing this will return us a slice containing the elements 0, 1, 2, and 3, because we are getting the elements starting from the left to the right of 0 to 4, not inclusive. So that means we get elements 0, 1, 2, and 3. So we get this returned to us. The last value here is not inclusive, so we do not get the value at index 4, which is this 4 here. And then I will show you an algorithm that we can use to remove an element from a slice at a certain index. So this is the algorithm. Slice equals append. Slice, semicolon, index of element to remove, comma, slice, index of element to remove plus 1, ... This will make more sense once we go through an example in code. But this is the algorithm to remove an element from a slice at a certain index. Coming back to our Visual Studios. So first, let's go over the slice operator before we talk about removing things, because you need to understand this first before we can understand that algorithm. So let's create a new slice. Whoops. And we'll just make it hold integer types to make this easy, and we'll have the length as 20. And we'll populate. So right here, all our 20 elements are 0, and I want to change that. So let's start a for loop right here so that I'll set the values from index 0 to 19 as counting by 2s. So at index 0 as the value 0, index 1 as the value 2, index 2 as the value 4, and index 3 as the value 6, and so on. So writing a for loop here, I is less than the length of new slice, I plus plus, and we'll say new slice at I equals I times 2. And then if I print this, new slice, we should see our slice with the values that I just mentioned earlier. And yep, so our 20 size slice has the value 0, 2, 4, 6, 8 counting by 2s up to index 19, which would have the value 38, so that's correct, because 19 times 2 is 38. So now, to demonstrate the slice operator, let's say I wanted a slice that contains the first 10 elements in new slice. So half of it. So what would it be? 0 to 18, I believe. Well, we could do this. Right. New slice 2, and we'll give it the slice returned using the slice operator. So we'll type in new slice. So we want the elements in new slice from starting at index 0 up to index 10, not inclusive. So writing this means that we want to return a slice containing the elements in new slice starting from index 0 up to index 9, because 10 is not inclusive here. So now if I print new slice 2, sorry, I should get 0 to 18, I believe. That's actually half of it. Yeah, so I get half of it. Now, and you can start from the back too, actually. So to demonstrate that, let's create another slice, and we'll call it new slice 30. Let's say I wanted the value starting from the back up to index 15. So this is 19, 19, 18, 17, 16, 15. So we would get these. So we want the value starting from the back up to index 15. And at index 15, the value is 30. So this is the slice that we want. Let's say that's what we want. Then we would say new slice at 3 is equal to new slice using a slice operator. We use our semicolon and then 15. Or no, sorry, it should be 15. And then semicolon. If you leave nothing here, if you leave the right side here with no value, that means all the way to the end. Just go all the way to the end. So now if I print that, as you can see, we get 30, 32, 34, 36, 38. The 5 values from the back. Okay, now let's go over removing elements from an array. Or not from an array, from a slice. So let's say we wanted to remove the element 18 from new slice. Element 18, let's say we want to remove the value of 18 from our slice. The value of 18 is at index 9 in this slice. So following the algorithm that I have here, index of element to remove, we would substitute that with 9, because at index 9 has the value of 18, which is the value that we want to remove. So here we would put in 9 as well. So following that algorithm, let's do this. Remember, append returns a new slice. So new slice equals append new slice from the start of our slice up to 9, comma, new slice. Remember, it's index to remove +1, so now it's 10, semicolon, dot, 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 and this will remove 18, the value of 18 from our slice. And to show you that that worked, I will print our slice. And as you can see, the value of 18 is removed. 10, 12, 14, 16, 18 was removed, 20, blah, blah, blah. So how does this work? Well, if you remembered, append returns a new slice. So whatever slice this append function returns is getting assigned to this new slice variable. And the first argument is the slice that we are adding onto. So the elements of this slice are being added on. So the elements that we want to add on to this slice. So what do we pass in here? So what does this say here? We're saying that the slice we're passing here is all the elements starting from the left of new slice, starting from 0 up to index 9, not inclusive. So from index 0 to 8 is the slice we're passing in as this first argument here. So 0, 2, 4, 6, 8, 10, blah, 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 so up to 16. This is what we have here. That's this slice. So this line right here represents this slice right here. And then we're adding onto this slice everything starting at index 10 to the end. So everything from index 10, which is starting here, to the end. So what we're doing here is we're taking this slice and we're adding onto this slice everything starting at index 10 to the end. So everything from 20 to 38. So this is the slice that we get back, which has 18 removed. This dot, dot, dot is for a variadic parameter, I believe is pronounced. So all you have to know is that what this does here is just that it'll unpack all the elements in the slice into like individual arguments. So this would be similar to me saying up here like append let's say, so this would be the same as me saying append 20, 22, or 20, comma 22, comma 24, comma 26, blah, 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 all the way to the end. this is just a shorthand, so we don't have to type all that out. And then, yeah, we just print that here. So that's pretty much the gist of slices. It's not too complicated. And so I mentioned we were going to be doing a project on creating a deck of playing cards. And so we're going to start that here. And we are going to use everything we learned so far to create a function that will create a new deck for us, create an initial deck for us. So I'm going to, I'll just use this same file. I'll just remove everything for now. No, I don't feel like making another file. Like I said, all the code is going to be on GitHub in the video link, so it doesn't matter. Okay. So, right. So we write function main, and now we have to write a function that will create a deck of playing cards for us. So I'll call our function newDeck, and what our new deck will do is return a slice of strings, and it does not take any parameters here. It won't take any art. There will be no parameters here. So this is gonna be a little bit of small algorithm here. Nothing complicated at all. So first, we need to create a slice variable that's going to return from this function. So I'll call it newDeck, and initially so I'm just going to create this with nothing in it, and then we'll need to create 2 arrays. And I'm using arrays here because these values don't change. And these 2 arrays are going to be holding the card suites and card values. So there are 4 suits here. So that's why I'm going to be using an array, because the number of suits will never change. It's always 4, at least for a standard deck here. So in here we're going to pass in 4 strings: hearts, spades, clubs, and diamonds. Okay, and then we're going to need another array for the card values, from ace up to king. So that's a size 13 array that I'm going to need. Give me a string, and then I already have it written out here, so we don't have to waste our time typing all this. I'm just gonna copy and paste this from written before. Okay, let me save that really quick. So we have 2. Why is this giving me a red squiggly? Oh, I'm missing. Okay, don't worry about that. So I created 2 arrays, one size 4, one size 13, to hold the card suites and card values. And I'm using arrays here because I know the size it should be and should not change. And now every suit has 13 cards. So I'm going to do 2 for loops. This is going to be an O(n squared) time complexity operation here. So we're going to be using 2 for loops here. So for the outer for loop, it will be all of the suits, and then for the inner loop, it's going to be all of the values. Cool. So newDeck equals append newDeck, comma, card values at j plus of plus card suit at I. So save that, and then we'll return our new deck here. So what does this double for loop do? So what we're doing is, in the outer loop, we loop 4 times in the outer loop for each card suite, and in the inner loop we loop 13 times for each card value. So each suite will get paired up with one of the values. And then each time a new card is created, we just append it to our new deck string slice up here. So for example, in the first iteration of our loop, I is 0 and J is 0. So that means we append into our new deck slice ace of hearts. And now we're still in the inner J for loop because it's not done yet, because it didn't go all the way to the end. So I is still 0, but J is 1 now. So J at index 1 has the value of 2. So now we append 2 of hearts into our new deck string slice. And it just keeps going through every suit. And then we finally return that new deck slice from our function. So to show you that we get all 52 cards, I will create a cards variable and assign it the string slice return by calling the new deck function, and then I will print every card in the string slice. Range cards if I mod 15 0. You don't need, you could just this modulo thingy here is just so that every 13 cards I'm going to print a new line, so it's just easier to read. This should be printed out here. Oops. And then to show you that we have 52 cards, I will also print out the length of our string slice. And here we go. Let's see. So as you can see, we have 52 because we have 52 playing cards, and then so ace of hearts, 2 of hearts, 3 of hearts. Actually, let me add a space after here. So it should look a little better. Okay, yeah, so ace of hearts, 2 of hearts, 3 of hearts, blah blah. Yep, queen of hearts, ace of spades, 2 of spades. So each suit gets the 13 cards that it has, as you can see. So we create our function that will return us a new deck of playing cards. We're going to modify this later so that it's a little more, I guess, sophisticated, but it's pretty good for now. We used everything we learned so far. So as a wrap up, what we learned in this video is what an array is, how a slice is represented internally in Go, how to declare and initialize a slice, the 2 ways, how to append new elements to a slice, how to remove an element at a certain index in a slice, how to copy a slice to another slice, and how to get the length of an array or a slice using the built-in length function. And we started our deck project here and created this new deck function. So in the next video, we are going to be talking about custom types and receiver functions. So that'll be fun. So thanks for watching, and see you in the next video.